Okay, everybody, let's do another solving with the simplex method example. So this time we're going to do just a 2x2, well, a two-dimensional example. So they've used an X and a Y. This one we could do by the graphing method with the method of corners, which we talked about in last week's lesson. But just to show that this method works for this scenario as well, we're going to go ahead and do one this way. So we are going to first write our constraints as we're going to change them from their inequality version to their equation version by adding those slack variables in. So we have x plus y, and I'm going to use u just because that's a common slack variable. And then 2x plus y plus, and you need something else for the other one, so v would make that equal 5. And again, you can use whatever you want, technically, just something that you distinguish from the other variables. And then the second thing we want to do is rewrite our objective function, so the p function, set it equal to 0 by subtracting everything over to the left. So negative 3x minus, because we're moving over, minus 4y plus p equals 0. Okay, and then we're going to set up our initial Tableau. So we have x and y and u and v, p, and our constants. So the first constraint gives us 1, 1, 1, 0, 0, 4. The second one gives us 2, 1, 0, 1, 5, 1, 0. There's no p's. 5 being the constant. And the objective function below the line gives us negative 3x, negative 4y, no u or v, a p, set equal to 0. Okay, so now we want to find our pivot column, pivot row, and pivot element. The pivot column is wherever the most negative value is in that objective function. So that would be our negative 4. That would be our pivot column. Then we need to move over and find our ratios in order to figure out our pivot row. So this is where we take the constants, so in this case 4, and divide it by whatever element is in that pivot column. So 1 in this case. And this one would be 5 divided also by 1, which is 5. So the smallest non-negative entry there is this one, the 4, giving us our pivot row, which means the element that they have in common is this 1, the pivot element. Okay, so we want to pivot about this 1 under the y. And so the first thing we would want to do is turn that into a 1. So that's done already. We don't have to do that step. We want to then just change the 1 below it and the negative 4 into zeros. So in order to change that 1 into a 0, we would need to do negative 1 times row 1, add it to row 2, and that would give us our new row 2. And we would also need to do a positive 4 times row 1, add that to row 3 to get our new row 3. Okay, at this point, you're going to want to go ahead and enter into your calculator. I would just override your matrix A. It's easiest if you always keep it as matrix A just because it's on the top and it's easy to get to. So I would override that with a new 3x6 matrix and go ahead and type all of these beginning entries in, and then we will start working on it. I always forget to do this and I mess up, so make sure once you get that matrix in, make sure you quit and then go back into the matrix area to do a matrix math. So we have to be doing these calculations back out on that home screen. If you're doing them and you're like inside the matrix area when you're doing them, you're going to get an error. Okay, so the first one we want to do is a times row plus, where we take negative 1 in matrix A. We use row 1 to change row 2, close it up, store, back in matrix A. Okay, so this we're using row 1, so actually whenever I go to write my next Tableau, which I should get ready here, We're using row 1, we're not changing row 1 at all, so I'm going to just rewrite it 111004, but I just changed row 2 to be 1, 0, negative 1, 1, 0, 1. Then let's change that bottom row by doing a second matrix math, go up to times row plus again. This time we're going to do 4, matrix A, comma, and this time we're using row 1 to change row 3. Store, second matrix A, and what we get is we have 1, 0, 4, 0, 1, 16. So this is really nice. It only took one iteration. This was a great one to do. It only took one iteration to be optimal. So we're optimal here because everything in this bottom row left of that line is positive now. So let's go ahead and denote our unit columns. So the Y is a unit column, the V is, and so is the P. So let's see, we've got then that Y is 4, the V is 1, and the P is 16, and then the other variables, the ones that are not in unit column form, remember, are zeros. So the X and the U end up being zeros. What would be important here then would be that P is what we wanted to maximize. So it looks like the maximum value is 16. And at the point, where does that happen? It's at the point 0, 4. So the max value is 16 at the point 0, 4. So again, because this was two-dimensional, we could have done it by graphing it, finding all of the corner points, checking each corner point in 3x plus 4y. The max number we would have got was 16. It would have happened at the corner point 0, 4. So we could have done it that way, but just to show you, this way works for any dimensions from 2 on up. Mostly we're only going to stick with 2s or 3s in this course, but we could extend it beyond that if we wanted to.